All right, we're back. Welcome to your Friday lecture, part two. Today we're talking about grouping the elements. We spent a lot of time talking about how we classify elements as being either metals or non-metals or metalloids. As a reminder for us, those metals are found on the left-hand side of the periodic table. All these cool cats are this way. Your non-metals are found towards the right of the periodic table, with your metalloids hugging that stair step that comes down this like weird, I don't know, like right-ish zone of the periodic table. What we're going to look at here today is how we can more specifically describe some of our elements on the periodic table. We've talked also about things like periodic law and Moseley's contributions to the periodic table. So far we've discussed periods moving across, or trends moving across the periodic table, right? Things get less metallic as you move towards the right of the periodic table. They get more metallic as you move towards the left of the periodic table. As we move forward from here, we're going to say that looking at elements going sideways on a periodic table are called periods. So one row on the periodic table is a period. Today we're going to talk about groups on the periodic table. And a group on a periodic table is a column. It's one of those up and down pillars that we find. For example, if you're looking at a periodic table, which I suggest you do at this point, if you haven't whipped out a periodic table, do so now. Preferably the one that you colored last time we chatted. It looks something like this. Good, way to get it out. If you look at one of these columns, for example, you start at the top and you look at hydrogen. Underneath it, we have lithium, sodium, potassium, rubidium. That is one group on the periodic table. And some of these groups we find have similar properties because, again, this periodic table is a pinnacle of human achievement and everything is nicely spaced. So we're going to talk about specific groups on the periodic table today and how they are cool and have cool features. Again, if any questions pop up in the meantime, I'm on Zoom. Give me a shout out. All right, let's get going. Sharing my screen with you today so you can see things. All right, so we're getting started here today. Titling this page here, grouping the elements. It's in your table of contents. You put a date and a page number. If you are someone who wants to watch it all the way through and then copy from the scan version, go for it. If you want to pause me along the way, whatever works, I could care less. But today we're going to look at how we group elements together in groups on the periodic table. So this is the periodic table as we know it right now, right? We've got our metals over this way, our non-metals over this way, and that super cool stair step denoting the location of our metalloids. Today, again, we're going to talk about groups on the periodic table. So these up and down columns of elements that also tend to have similar properties. So as a reminder for us here, periods are going sideways across the periodic table. We would say hydrogen is in period 1, lithium is in period 2, sodium is in period 3, et cetera, et cetera. So we're talking about groups. So we're going to look at group 1, which is this first column, group 2, which is the second column, groups 3 through 12, which are these guys here, the short little bit, and then group 13, 14, 15, 16, 17, 18. It's gonna be great and we'll have a real good time. So we're gonna start here on the far left of our periodic table with these red elements, which are gonna be group 1. They're the first column you come across on the periodic table and they have a fancy name for themselves. We're gonna call these the alkali metals. We know that these are all metals because they're on the left-hand side of our periodic table and we're looking at elements in that first group. We give them a cool name because we're just like fancy like that, I guess. No big deal. So in this group, we have a couple different elements. How many do we have? 1, 2, 3, 4, 5, 6 elements that are all metals. And they're all metals, again, because they're on the left-hand side of the periodic table. So they have all those metallic properties. They're shiny, they're malleable, they're ductile, they're good conductors of electricity. And they're gonna have few electrons in their outer level. In fact, these guys only have 1 electron in their outer level. They have 1 valence electron, and all they wanna do with their element life is get rid of it. That's all they want to do. And it is so easy to get rid of 1 electron. And because it is so easy to get rid of 1 electron, the elements in this first group are going to be like crazy reactive. They are so incredibly reactive. They are so reactive. I cannot stress enough how crazy reactive they are. I have a couple YouTube videos here that show just how reactive they are. These are types of elements that will explode with water. They'll explode when exposed to air. Like they are crazy reactive. I'll post the links here on Google Classroom so you can watch them at your own personal leisure. But these guys, so reactive. Cannot stress enough. Group 1 is very reactive. I've highlighted it here because if you remember one thing about your alkali metals, it should be that they are so reactive. So reactive. And another piece I want to point out here, which is a little bit weird, but you'll notice on this periodic table, hydrogen is floating kind of in this weird space. Hydrogen is not truly a member of group 1. It is not classified as an alkali metal for a couple reasons. Number one reason being it's not a metal, right? Hydrogen is a non-metal. It should kind of exist actually over here, but it's not technically part of group 1. So when we talk about these alkali metals, we're talking about everything in this first column except for hydrogen. Super reactive. Super, super reactive. Okay, moving right along. As we move towards the right-hand side of the periodic table, we're going to look down at that second major column. That second major column is our alkaline earth metals. Sometimes they're just called alkaline metals. I like to call them alkaline earth metals because I think it sounds cooler. But this is that second column on the periodic table between the lithium column and the Scandinavium column. Starting here with beryllium up top, moving all the way down to radium. These guys here again are also metals. It's in the name, right? They're alkaline earth metals. They're on the left-hand side of the periodic table. So they have metallic properties. They're shiny, they're good conductors, they're malleable and ductile, and all those cool things. These guys here, again, because they're metals, have few electrons in their outer shell. But instead of having one, like your group 1, these guys have 2 electrons in their outer shell. 2 electrons in their outer shell is not a lot. It is super manageable, super easy to give them away. So because they only have 2 electrons in that outer shell, they're still going to be reactive, but less reactive than those group 1 metals. It's much easier to give away 1 electron than it is to give away 2 electrons, but it's still pretty darn easy to give away 2 electrons. So elements in this column are also super reactive, but are not going to react with things like air or water unless under like special circumstances. So big takeaway here, group 2, 2 valence electrons, super reactive, but not as reactive as your group 1 metals. Okay, moving on, we're going to cover a big swath of the periodic table here. We're going to group together groups 3 all the way through group 12. This is a big chunk. We're going to call these guys here the transition metals. Believe it or not, they're metals. They're going to be metals for 2 reasons. 1, it's in the name, and 2, they're on the left-hand side of the periodic table. Your transition metals are going to be everything on these short blocks, including these 2 periods at the bottom of the periodic table. These guys here technically belong in this like little missing hole right here, but if we actually put these 2 rows, I guess, in this little block, our periodic table would be like really long and bulky and like hard to use. So what we've done instead is pulled them out of the periodic table and just stuck them on the bottom. So we can be like, yeah, they belong there, but it looks nicer if we stick them here. As a whole, elements in these group 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 10 groups are all metals. So they are shiny, they're ductile, they're malleable, they have few electrons in their outer level. These guys here are going to be more stable though than group 1 or 2 metals. As a whole, they're less reactive, they're more at peace with their electron configuration, they're less likely to react with things like air or water. The big takeaway for us here with regards to our transition metals is that even though they're all very different from each other, they're all metals and they all do metallic-y stuff. If we look at something like silver, silver looks physically very different than gold, right? One is shiny and silver and one is gold. They're different, but they have similar properties, right? They're both good conductors, they're both shiny, they're both malleable and ductile. If you look at something weird like mercury, which is a liquid at room temperature, it's very different from something like titanium, which is also a transition metal, but they're both metals, so they both do metal stuff, right? They're shiny, they're ductile, they're malleable, good conductors of electricity and heat. So big takeaway here, your transition metals kind of make up a big part of your periodic table, but in general, they all do metallic-y stuff. Those 2 weird groups at the bottom have specific names. We're going to call the top one the lanthanide series or the lanthanide period. If you look at the first element inside the lanthanide series, what's it called? You're right, it's lanthanium. Whoa, that's where the name comes from. How cool is that? It's kind of weird. It's a transition metal group. There's the bottom of the periodic table. They're shiny metals. The period underneath it is called the actinide series, again, as part of your transition metals. First element in that one is actinium. Again, all shiny metals. Cool thing about this group is that you tend to have your weirder elements in it, all your radioactive or super unstable elements. In fact, all of those elements after plutonium, which has atomic number 94, are all man-made elements. They're elements that someone actually like physically fused protons together in order to create some new element. So they're not naturally occurring elements, but they are still technically elements. We're gonna hit like a boring swath of the periodic table right now. Groups 13, the one that starts with boron up at the top, is like, okay, it's got some metalloids and mostly metals in it. It has 3 electrons in its outer shell. They're metals for the most part, except for boron, which is a metalloid. And you're like, okay, cool. That's all we care about. Carbon is in kind of a unique situation. So group 14 is that column between boron and nitrogen. It's got carbon up at the top and then lead all the way down at the bottom. This group is a little special because they have 4 electrons in their outer shell. 4 electrons in their outer shell puts them at kind of the sweet spot. They can either gain 4 electrons to get that full octet of 8, or they could lose 4 electrons in order to reach that full outer shell, which gives the elements in carbon's group a lot of flexibility because they could either gain or lose electrons, which makes them like fancy elements. For the most part, they tend to all be solids at room temperature. Elements at the top tend to be more reactive than those elements at the bottom. And you have a smorgasbord of different types of elements in this particular group, right? Carbon is a non-metal, silicon and germanium are metalloids, and the rest of them tend to be metals. So big takeaway here for your carbon group, 4 electrons in that outer level. Nitrogen group is group 15. It's got nitrogen at the top. This is kind of like the boron group. We don't really care a whole lot about it, except for it has 5 electrons in that outer shell. Moving right along, same story here with oxygen. Oxygen is group 16. It's between nitrogen and fluorine. And they have 6 electrons in their outer level. Have we started to see a pattern yet? Group 14 has 4 electrons in their outer level. Group 15 has 5 electrons in their outer level. Group 16 has 6 electrons in their outer level. Group 17, how many electrons are they going to have in their outer level? You're right, 7! So group 17, it's the one with fluorine right at the top. It's the second to the last group. These are called the halogens, and they're no big deal, but like my favorite group on the periodic table. So your halogens are special for a lot of reasons. Number one, these guys are all non-metals. They're found far to the right on that periodic table. So they are all non-metallic, not shiny, not ductile, not malleable, not good conductors. And these guys have 7 electrons in their outer level, which means that they are 1 electron away from reaching that magic 8. It is so easy to gain 1 electron. In fact, it's almost equally easy to gain 1 electron as it is to lose 1 electron. So these guys are going to be very, 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 very reactive. They are kind of the counterbalance to that group 1 that only needed to lose 1 electron in order to have that full octet. So these guys here are super, super reactive because they only have 7 electrons in their outer level. And as we look at the elements in this particular group, we're going to see a wide variety of chemical and physical properties. This guy here is chlorine gas. It's like a yellowish gas. It was used in warfare. It's kind of terrible. This is liquid iodine. It's like brown. It's a brown liquid. So we have a gas, we have a liquid. They're drastically different colors. A wide variety of chemical and physical properties in this particular group. And then last but not least here, we're going to hit that final group on the periodic table, that last column, the most right column. This is group 18. Using that previous trend, how many valence electrons should group 18 have? 8! You're right! What? They've got that magic number. That's so exciting. Good for them. We're like super proud. We're going to call this group here that starts with helium at the top with noble gases. Call them the noble gases because they're all nonmetals. In fact, they all tend to be gases. Incredible. These guys here have 8 electrons in their outer shell, which means that they are unreactive. They don't want to lose any electrons and drop down to 7 or 6. They don't want to gain any more electrons. They are fully happy with their 8. And because they already have those 8 electrons, that full outer shell of electrons, they are non-reactive. They are not going to react with anything. They are too good for the rest of the elements. Except for helium, which is kind of a weird situation. Helium is too small to have a lot of electrons, so it only needs 2 electrons in its outer shell, which counts as a full 8. for helium. So we're going to say that even though helium technically doesn't have 8, it still has a full outer shell, so it's also non-reactive. Big takeaway for us here is with group 18, full outer shell, no reactions. All right, so all of those like neon lights that you see, those are all an inert gas. Those are a noble gas. They don't react with anything. They don't catch on fire or nothing. And then we hit hydrogen, which is kind of a weird thing here. Hydrogen is sort of in like a group by itself. It does not belong to group 1. It is not an alkali metal, even though it only has 1 valence electron. It's not a metal, so it doesn't fall into that category. It's kind of special. It like kind of does its own thing. It has 1 electron in its outer level. It's super reactive. It's a gas. It explodes with oxygen. It's used in rocket fuel. That's going to kind of summarize us here. So if we were to take away a couple things here from this discussion, let's see, give me 30 seconds. Ooh. Stop share. All right. So if we were to take away a couple pieces from today, we would take away this. Group 1, super, super reactive. Group 2, less reactive. Groups 3 through 12, transition, all metals. Group 14, 4 valence electrons, so cool. Group 17, halogens, 7 valence electrons, really reactive. Group 18, noble gases, never react. That's what we got. Not so bad. Okay, if you have any questions, hop on Zoom. I'll see you after the function. Oh my God, that was good. Okay. I think that last bit was